So identifying the sides, really, really, really important. Identifying them by name. That's how we started this whole process off. So if this is my perspective, which side is my opposite? Okay. Oh, there, where's it going? Okay. And again, I can always tell the opposite by simply going through the perspective and the side across. That's the opposite. Which side is the hypotenuse? Should be easy to identify. Okay, that's my longest side. It's my hypotenuse. So this must be the adjacent. Next, I figure out which sides are in the mix for this particular problem. Okay, so I look at that and say, all right, the sides we're working with are the 17 and the x, so we're working in this particular situation with the opposite and hypotenuse. And on the top of my paper, I've written so, ka, toa as a nice reference. So if I'm working with the hypotenuse and the opposite, which function do we need to choose? Which tool? Sine. Yep, sine. So sine is the function we're going to choose because it's opposite hypotenuse. Sine. What goes right after a sine or cosine or tangential is? What do we put in there? An angle. Okay? That angle for right now is a number that we know. If it's an unknown, we'll just put the variable that goes with it. But in this case, it's a 24-degree angle. And then we set up a ratio of sine, and SOHCAHTOA tells us the order of the ratio, top, bottom. Opposite is on top, x is on bottom. When the x is on bottom, what do we, now we just solve the equation. Now we do the algebra. When the x is on bottom, what do we do? Yep. Because remembering that sine 24 represents a decimal value. So I can't separate the sine and the 24. I can't add, subtract, multiply, or divide this number 24 when it's with the sign. All right? They go together. So that's a unit. It moves. And the x moves. So x equals 17 over sine 24. And I get my calculator. 17 divided by sine 24. I get that that's 41.8. And of course, the final thing, like we do with any question, we ask, does that make sense? 41.8 is way bigger than 17, but 17 is the shortest side of my triangle. I would expect my hypotenuse to be significantly larger. Okay? So that does make sense. And that's how we set up these problems. Slowly, step by step, doing the little things, they're going to help you be successful in the end and set up the right equation. All right, let's do a second one. So this is 41 degrees, and this is 18, and this is 16. No, I didn't want to do that. That's too much. X. I need an X over here. There we go. Thank you. All right. So, what's my perspective? The 41 is my perspective. Okay? So if the 41 is my perspective, now which side is which? X is the opposite. 18 is the adjacent. And this must be the hypotenuse. Okay? Well, it's not involved at all. So now I got opposite and adjacent in play. Which function do I choose when I have opposite and adjacent are the two in play? Tangent. And if you're not sure, you look up. SOHCAHTOA. That uses a hypotenuse, not in play. That uses hypotenuse, H, not in play. Oh, this uses opposite adjacent. That's the one I want. T. T stands for tangent. Now I set up my equation. Tangent of the angle equals, and this even tells me the order they go in the ratio. SOHCAHTOA even tells me the ratio order. So opposite over adjacent. So x over 18. Aha, the x is in the top this time. So multiply both sides by 18. Now notice it's not the 41 that's being multiplied by 18, it's the value tan 41 that's being multiplied by 18. So I'm going to do 18 times tan 41. And I get 15.6. Actually, I think 15.7. Does it round up? 664. You're right, it does. Okay. So 15.64, so 15.6. And we're all set. We solved our unknown side. All right. So that's what we were doing on Friday. Today, oops. Today we're continuing with this, but we're going to switch things up a little bit. Now, we've known for a long time that the value of sine, cosine, and tangent has a decimal value. Well, the way we used to do this, back before the calculator days, is we had this information. We had a table of values for sine, cosine, tangent. This table includes a couple things we do not work with here. First off, the angle measure in radians. We aren't using radian measure to measure angles. So you don't have to worry about that, but that's in there. Just for fun, 180 degrees is the same as pi radians. So a full circle is 2 pi radians, which goes right with the equation for circumference of a circle, which is 2 pi r. That's where radian measure comes from. Not that you need to know that, but kind of an interesting little fact. But we aren't going to worry about radians for now. It also has 3 other functions here: cot, CSC, and SEC. Those stand for secant, cosecant, and cotangent. Those are other trig functions that we will not be working with. Okay? Really, they're just these functions reciprocals. Like if you do the reciprocal of sine, sine is opposite of hypotenuse. If you do the reverse ratio hypotenuse over opposite, you get cosecant. But that would just be way too much confusion for us at this level, so we're not going to worry about that. All right? So it's not that much more complicated, but sine, cosine, tangent are really enough for our purposes. Okay? But notice what we could do in this table is I could look up, say, well, think I have a 19-degree angle. I'm not worried about that. What's the value of sine, cosine, and tangent for that angle? Boom, there it is. The sine is 0.3256, the cosine is 0.9456, and the tangent is 0.3443. Boom. That's how we do that. We would look it up, and then we plug that number in instead of using a calculator. You're not going to have to do that, but that's how we did it. But it means the opposite is also true. If I know the value of sine, cosine, or tangent for my angle, if I know that decimal value, I could look that up in my chart and figure out what the angle is, couldn't I? In fact, we did that on our very first day. We didn't look it up, but we did that. We said, okay, I've got some right triangle here, and this side is 10, and this side is 17, and this is angle A up here, and this is angle B, this is angle C. And if I want to know about angle A, what is the sine of angle A? Well, what is that? What is the ratio? Sine is opposite over hypotenuse. Which side is the opposite? Which side is the hypotenuse? This is the adjacent. Okay, so the sine would be 10 over 17, which then I converted to some decimal value. We did this in our homework. 10 divided by 17 said 0.5882. And then what we could do is we could go back to our chart and look up what angle has a sine value of about 0.5882. Ooh, Right here, down here at the bottom of my list, 0.5878 is really close. So that's just about a 36-degree angle. It's a little bit more. Okay? So we could set up our ratio, change it to a decimal, and figure out what the angle measurement was by looking that up in our table of values. But we don't have a table of values anymore. What do we have? We have a calculator. So this is where our inverse functions come in. Okay? This is where we get our inverse functions. Inverse functions are used when what is unknown is the angle. By the way, this is in your first notes here. Okay? In order to find the measure of an unknown angle, we use an inverse function. How do I know it's an inverse function? Well, it's in the notation. Notice this little -1. Okay? That's representing that we are using an inverse function. When we see a -1 as an exponent above a function name, that's representing an inverse function. If I see a -1 on a variable, that means a reciprocal of the variable. That's a completely different meaning. You will not use the x -1 button on your calculator for this. Okay? You will not use the x -1 button. That's a reciprocal button, not an inverse function button. Your inverse functions in your calculator, you locate by they're right above the regular function buttons. You get to them by pushing the second function button and sine, or second function cosine, second function tangent. Look at your calculator right now. If you just look above the sine button, you'll see it says sine -1. That's sine inverse. And above the cosine button, it says cosine -1. That's the cosine inverse. And you access that simply by hitting the second function button first, and and then you get to your second function. Okay? And you're in your inverse function. So that's how we access and tell the calculator to look up what the unknown angle is. So when we're using the inverse function, we are looking for an unknown angle. We don't use the inverse functions when the side is what's unknown. We use the inverse functions when the angle is what is unknown. So we're going to break this down into 4 steps, basically, which, again, are in your notes. By the way, big hint, if you're taking notes on your own, when you get someone says, okay, here are the steps we're going to do to solve this. These are the steps. That's something you would put in your notes if you're taking your own notes. That's something that you would do. So the step 1, we got to pick the angle we want to work with, okay? Because right now I could work with any of my acute angles. Again, we're only working with right triangles. My right angle is up there. We are not going to work with that. It's one of the 2 acute angles, and you need to pick which one. Why? Because if you don't pick an angle, you don't have a perspective. You don't know which side is which. So you got to pick an angle. Which angle would you like to pick? D or F? F. F it is. Okay? So we pick our angle. What do we do next? Every time we pick an angle, we identify our perspective. What's the next thing that we do? We always identify our sides. Which side is opposite, which side is hypotenuse, which side is adjacent. Because without that information, I cannot proceed. And this is a step you do not want to skip. Writing it out, just count on recognizing it in your head because you will mess it up. So if F is my perspective, which side is the opposite? 50, it's actually 51, but okay. You're far away and that number's not huge. Which side is the hypotenuse? The bottom, right, that we don't know? And that 37 is the adjacent. Okay? And now this is just like what we did the first day. We pick a trig ratio and we set up our trig ratio with our unknown being an angle. So the sides that are in play right now are the opposite and the adjacent. So if I have my SOHCAHTOA written up here, okay, which function is opposite and adjacent? Tan. So tan is the function we're going to pick. We're going to set up our equation. The tangent of f, because tangent always must be associated with a perspective. I never write tangent equals, because I always have to have an angle, tangent of an angle. Without perspective, there's nothing that we can do. Okay? Equals, and this is just what we did the first day. What's the ratio going to be? TOA. Remember, the SOHCAHTOA doesn't just tell us what goes with what. It also tells the order, opposite on top, adjacent on bottom. Right? So 51 over 37. Now, I could turn that into a decimal and look it up in my chart, but that's really not necessary. Here's where our calculator is really nice. Now we do the inverse function. Now we go to the tangent inverse button. And we put in our ratio. 51 over 37. And we will get out our angle. So we go to our calculator, put in our second function tangent, and then 51 divided by 37. Don't use the fraction key. Make sure you hit the right numbers. Check your equation to make sure it has the right function and the right numbers in it. Hit enter, and I get 54.0 degrees. Now, if you have one of the classic calculators, you have to change it to a decimal first. 51 divided by 37 equals, and then do second function tangent, if you have a classic. Okay? Yes. Yes, because it's rounded to the nearest tenth. That tells me that that's a rounded number to the nearest tenth. If you just leave 54, I think it's rounded to the nearest whole number. Okay? Because it's not exactly 54. Okay, and guess what? If I know that angle's 54, now I know that this angle has to be 36 degrees, 0.0. Because the two acute angles have to add up to 90. So if I found one angle, I automatically get the other one just by triangle sum. I don't need to do it twice. But that's our process. So, when solving for an unknown side, we use the regular function, sine, cosine, or tangent. When solving for an unknown angle, we use the inverse function. This is a sticking point for a lot of people. When do I use the inverse? Because, the inverse is the last one I got learned. I was going to say that's terrible English. The inverse is the last one you've learned, so some people like to go, okay, so that's one I'm going to use all the time. No. We only use the inverse function when we are solving for an unknown angle. Inverse function is an angle, looks up the angle measure. Regular function looks up unknown sides. Helps me find unknown sides. So if the angle is known, I'm not going to use the inverse function. So knowing when to use what is important. And your worksheet today is going to have front side is going to be all inverse function problems, find the unknown angle. The back side is going to be a mix. We have to start choosing. What am I going to do? Am I using the regular function? Am I using the other function? So how about this? Let's solve for the question mark. Okay? Solve for the question mark. So what are we going to do? We're going to identify an angle that we're working with. We want to solve for u. We're going to identify our sides. Which side is the opposite? Which side is the hypotenuse? So this must be the adjacent. Okay? Which ones are in play here? Which sides are in play for us? Opposite and hypotenuse. Which function am I SOHCAHTOA uses opposite hypotenuse. Sine. So sine of the angle equals opposite over hypotenuse. I need to see that equation. And then we're going to rearrange that because I'm solving for an angle. I'm going to switch to the inverse function and put the ratio in here. And my output becomes my angle. Sorry, U. Okay. And now I go to my calculator. Sine inverse 35 divided by 37 tells me that angle is 71.1 degrees. Which means this would have to be 18.9 degrees. Because I have to add up to 90. Okay? So it's like a 2-for-1 deal. Once you find one angle, you just very quickly get the second one. Does that make sense? Let's do another one. Okay? I'm going to do a little rearranging. How about now? We identified this. We identified a perspective on the sides now, already by name, so we're good. Which function am I going to choose this time? Tan. Okay? Because opposite adjacent, so it's going to be tangent of u, again, equals 37 over 35. So now what am I going to do? I'm going to rewrite using the inverse, because and get in my calculator. 37 divided by 35. I get 46.6 degrees. So this is 43.7 degrees, or 43.4 degrees. Now, that's really close to 45, 45, 90. Why is that not surprising? Because these two sides are almost the same, aren't they? Okay. The sides are exactly the same, even 45 and 45. We wouldn't need our inverse functions. Now, to solve a triangle, this is the second part of what we're getting into. To solve a triangle now means to find all of the unknown parts of that triangle. So know all the sides and all the angles when you're done. Now, in this situation, I know the right angle and I know one other acute angle. Do I need to use trig to find that third angle? Absolutely not. Whatever you know two of, you don't need trig to find the third in this situation. If I know two sides, I can find the third side using Pythagorean theorem. If I know two angles, I can find the third angle by just adding up to 180. So this is going to have to be 73 degrees. That's all set. 17 plus 73 is 90, plus 90 is 180. That's easy. Now I got to figure out which side I want to solve for first. Do I want to solve for QE or WE? Okay, go with the QE. Does it matter which one you choose? Absolutely not. But you do have to pick. So I'm going to put my X over here. And then now I have to go through my process. Pick a perspective. Now, smarter to pick the 17 or the 73? Why is the 17 smarter? Not necessarily. That's not a good reason. Because we're 100% sure of the 17 number, aren't we? Okay? That's a given number. I'm 100% confident of it. I'm 99% confident of my 73, but what if I just had a complete brain meltdown and put the wrong number in there? Well, then everything would be off, right? So I want to choose a perspective of a given angle if I can. So this is my perspective. My sides. X is which side? This is the opposite. This is the hypotenuse. So this must be the adjacent. Okay, which sides are in play for this particular problem? Opposite and adjacent, so what function? Tangent. So tangent of the angle, which I know this time, so I'll put a measurement in there. I'm not going to put W in there. I'm going to put the measurement in. Equals opposite over adjacent. Oh, do I need the inverse function? No, don't need it, because I already know the angle. How am I going to solve this? Multiply both sides by 24. And get out the calculator, 24, 10, 17. Oh, let's hit a button wrong. Oh, there we go. 7.3, nearest 10th. Okay? Now, I still need to know the hypotenuse. So what I'm going to do now is I'm going to say, okay, this is now known. Now I'm going to go with the hypotenuse. I'm going to call this y. I don't want to use the 7.3 for the same reason I didn't use the 73. What if I made a mistake? I want to use the 24 and the y, which is the adjacent and the hypotenuse. Adjacent hypotenuse is which function? Cosine. So cosine of 17 is adjacent over hypotenuse. I can solve that. Just swap. $25.1. And now I know all the sides and all the angles of that triangle. I've solved it. That's called solving a triangle. Now, once I knew two sides, could I have used Pythagorean theorem to estimate the third side? Sure. I could have. But trig is actually faster and easier. Here, I want to solve this triangle. But this time I know two sides and none of the angles. So if I know two, remember, whatever I know two of, I'm not going to use trig to find the third in a right triangle. So if I know two sides, what's the quickest way here to find the third side? Pythagorean theorem. So 64 plus x squared is 289. So x squared is 225. And the square root of 225 is 15. Hallelujah. We're set. Okay? Pretty quick. And again, when we're in a trig unit, we're probably going to decimally approximate that to the nearest tenth if it's not perfect. All right, now I got to pick an angle to solve. G or D? Which one would you like? G, okay? It doesn't matter which one you pick. You get different ratios, we can get the same solutions. Okay? If that's the case, which side is the opposite? Okay? Which side's the hypotenuse? So this is my adjacent. Again, I'm going to work with the sides that I'm given because that's my best bet here. So I'm going to choose opposite and hypotenuse. Could I do adjacent hypotenuse? Yes. Could I do opposite adjacent? I could, yes. But I have to pick one ratio. And so the best thing is use the given numbers. Opposite hypotenuse is which function? SOHCAHTOA? Sine. So sine of my perspective angle, G, is opposite over hypotenuse. Oh, how am I going to get the unknown angle? Use the, when the angle's unknown, what function do we use? We use the inverse function. Sine inverse of the ratio, and I plug that in my calculator. .1 degrees. And now I could, this is going to have to be 61.9 degrees in order to balance that out. Okay? And I've solved that triangle. I know all sides and all the angles. up to now, you've never known how to find unknown angles in a right triangle. This is a new tool for you. Finding the third side has not been a big deal. We've had Pythagorean theorem for a long time. But now we can solve for unknown angles in right triangles, which is very, very powerful indeed. Okay? This is what you're going to be practicing for the few minutes we have left today and tomorrow when you're not in class at home. This stuff definitely shows up on the ACT. So the people taking the ACT tomorrow, which are none of you, are going to need to know this. So that means you will need to know it next year. So